I just want to tell you a little bit about myself. So my name is Rachel, as you can see, and basically I trained originally as an economist, but have kind of lately got into doing more work in what we would call sort of data science. But for most of the roles I've had in many industries, I've worked with data, either in analysing it or in visualising it, to build a story for people and to convey to people who don't necessarily understand that much about data and what that data is telling us. And if you want to follow me, please feel free to look at my repo on GitHub or to link in with me as well. So today, what are we going to do? Well, we're going to create some images with some data on the COVID-19 epidemic. And I always like this quote that a picture is worth 1,000 words, and that's very true. You can convey an awful lot of meaning through a visual, and Plotly is a very powerful tool for creating attractive visuals. But with that power, there's also comes a certain responsibility as well. As an analyst who is putting together charts or even telling a story with data, there is a responsibility to understand what you're doing and understand how other people are going to interpret it as well. And as I'll show you with a few of the things we're going to do, you know, there is an opportunity in the way in which you create the chart to convey different meanings and to lead the interpreter into a different understanding of what is going on. And more precisely, what I'm going to do today is introduce you to Plotly. I can't take you through everything. There is a lot to it, and as you'll see, there's a lot of different parameters within the library itself, so you can tweak all sorts of things. So there's no way I could cover it all today. But hopefully, I'm going to show you how to make some nice interactive charts with the COVID-19 data. And then perhaps you can take away that code and build on it and make your own versions or even apply it to different data. So I'm going to manage your expectations in terms of how much we're going to be able to get through today. And the thing you'll find about Plotly is the more you play with it, the more you find that you can do with it. We're going to start off by doing a little bit of data reading. I'm not going to go in depth into the data itself, but I will talk a little bit about it. So this isn't a class in epidemiology. And then I'm going to do a little bit of data wrangling with pandas to get the data in the right form that we need it to plot. And they're going to go through some basics, just making some very, very basic charts with Plotly, before going on to show you some slightly different things you can do, a little bit more fine tuning and some more complicated charts. And finally, and if hopefully we have time, I'm going to go through a little bit about how you might deploy this chart. So how you would make them into a dashboard, or how you might put them on the internet so that other people can see the results of your creative genius. Or indeed, if you're working in business, how you can share them between colleagues over the internet as well. So please do ask questions, and I'll pause at a couple of points to try and answer them. There are, as with all sort of libraries you might be working with, things that I don't know, but I can definitely go away and look them up for you. And I am also happy to follow up after this session as well if you've got more questions. So I'm not sure if you've been sent this information already, but there is a repo and you can see it here. So if you're comfortable with Python, with Anaconda environments, with doing install, then please do feel free to clone the repo and follow it along. I do warn you, if you maybe you've seen this if you've had a look at the repo already, there is quite a lot of installing to do to get Jupyter to Plotly to work with Jupyter. So it's not something that can necessarily be done in 2 minutes. So what I would advise you, if you're not super comfortable with GitHub or with Python or with Anaconda environments, that you just follow this session, and then perhaps afterwards you go back and go through slowly the steps for installing everything to make it work. And I'm going to keep this repo up and possibly keep working on it as well. So please feel free to go away, take the code, and do your own thing with it as well. So what is Plotly? So Plotly is an open source graphing library, which allows you to make high quality interactive charts. So an interactive chart is one where your user can actually do something with the chart. It can change elements of the charts. You might be able to pan in time or click certain series to go on and off, or to zoom in or zoom out of the charts as well. And especially if you're not necessarily an artist by training, it actually provides some very nice and professional looking templates for your charts as well, without having necessarily to do lots and lots and lots of coding. It also provides lots of functionality for integrating your charts into a web page, or just creating your own independent dashboard as well. Also, importantly, it's free, which is always good. So you're at liberty to play with it as you like. I'm going to talk about Plotly with Python, but it's also available as an R library and JavaScript as well, if you're more familiar with those languages. And as you can see on this slide, there is a link to the manual, which is actually good. I mean, not all library manuals are good, but this one has a lot of examples and is very clearly laid out. However, the one kind of health warning I would say is there is a lot to it, and it can be quite easy to get lost in the sort of small parameters and the sub parameters as well. So I mean, I guess I think as a tool it's very powerful, and you have some very nice visuals. I think if you are trying to make visuals for someone else, I would tend to still stick to something like Matplotlib if I was just making charts to have a quick inspection of something else, of some data. But this is a very cool piece of software. The other health warning is that, like a lot of things in Python, there are many ways to achieve things in Plotly. So I'm going to show you the way that I've put together these charts. There are different ways in which you can use the language that Plotly has. So when you go online and you look at other examples, you may actually see variations, which in many ways is quite annoying, because when you're trying to troubleshoot, it can get a little bit more complicated if the answer has been written in a slightly different format. But unfortunately with Python, that is something that you have to live with. So let's get started. So I'm now just turning to the repo itself for anyone who's following along. So I just want to give you a quick flash of what we are going to attempt to achieve today. If we don't get time to go through all of these charts, then the code will still be up there on the repo. But this is a Plotly Dash application with a number of interactive charts in it. I'm just going to talk you through a little bit about how we might construct some of these. And it's all relatively easy to do once you've got the basic code in place. Let's stop that. Right, so let's turn to the basic charts workbook. So first of all, let's talk a little bit about the data. So the data come from, and I always get this wrong, I think it's the European Centre for Disease, of the ECDC. And basically at this link, which you can see, so there's actually the explanations around the data. The actual data itself can be downloaded directly into Python using pandas, and it's republished every day at the moment. So every day when you refresh this workbook, you're getting an extra days worth of data. And just for those of you who are wondering why I put this argument, there's a weird formatting issue with one of the sort of small islands that's included in the data, which require you to select, specify the number of columns you want. So that's why that's there. And firstly, we'll just have a quick look at what's in the data. So essentially, you've got four columns. So first thing to say is it's relatively clean already, which is good. You've got 4 columns here dealing with different aspects of the date. So this is a full date. There's the day, the month of the year from that date. You've then got number of cases, and that's daily number of cases. You've got daily number of deaths. Then you've got the countries and territories, which is the full name country. And then you have 2 different codings for country names as well. And that's followed by some population data for each country. You can then also look at just a little bit at a snippet of the data, and you can see how it's laid out. I think just a couple of things to note looking at these 2 pieces of information. Firstly, we can see that most of the numbered categories are already numbers. They're either integer or floats. That's good. The one problem here is the date. That's not being recognised as a date time, which is potentially going to cause us problems later. And also, I don't know if you've noticed that actually the dates here are in reverse order well. So that here you've got the most recent date first. So just because the way we chart from left to right, we're going to want to reverse that. So the first thing we're going to want to do is make those transformations to data. So firstly here is I'm basically turning the date rep column into a date time format. What I'm then doing is sorting all of these values by country and by date and making them ascending. So this then sorts out the problem of all the dates being in the wrong order. And then I just re-index it, because for those of you annoying thing, the indexes don't change when you sort it, which can cause you problems later when you think you're dealing with sequential elements, but because they're indexed, when it was sorted in a different order, you end up with problems. Then let's have a look as well at what countries we've got in this data set. That's obviously quite long. It's good. We've got 204. So we've got a few, there's about 192 countries in the world. So we've got a few sort of extras. There's here you'll see there's cases on international conveyance in Japan, or that's the cruise ship in Japan. But one thing that... Sorry, please, can you
zoom in?
Zoom in, yeah.
Thank you.
Okay, no problem. So here you've got all of your countries. The one thing that's missing, which I would be useful, is an aggregate for the world. So what's the world total? Because it's not here. So I've just created a total. And what I've done is first just made a subset using the group by function, so grouping by date, and then summed all of the cases and all of the deaths. And what you get when you do this is this table. So you've got an individual row for each date. What you will notice is that the population data goes up a lot over a few days, and that's not because the world population has gone up. It's because there are some countries that don't start off in the data set, but later on end up in the data set as they start reporting data. So we've created your world. We now want to add it back into the original data set. So we just need to create some variables to match all the variables that are in the original data set. So that's what I'm doing here. And then we concatenate it back into the original. Well, we've actually made a new data set here. So we've concatenated it with the original data. And then what we can see now we've got entries for the world for each day in which there's been a report. So that's just some basic data manipulation that we've done here. So let's talk a little bit about the plots themselves. So to plot with Plotly, for those of you familiar with Python, you'll know you have to import Plotly. Throughout this, I'm using the plotly.graph object library and sublibrary. There are other tools, other wrappers for Plotly. So there's one called Plotly Express, which allows you to do quicker charts, but is far less flexible. So I haven't used that here, but just be aware there are other options for doing these charts. So the basic chart. So in your basic chart, you need your data. Here, all I've done is that I just want to select all the data relating to the world. You then have to allocate what you want on your x-axis. So here I'm going to put the date on the x-axis. You select your y-axis, what you want on your y-axis. So it's deaths, that's how the height of the bars. And then, so this is quite important, and this is fundamental to Plotly. You then have to describe the chart you want. So you'll often see these referred to as traces. So this is where you say, okay, I want a bar chart, and here's my X data, and here's my Y data. And you can then extend, as we'll see in a bit, this description of the chart to add further arguments. You then tell it to make the chart with a trace, and then certainly so you just need to say figure show, tell it to show the figure. And this is what you get. So within about that's 6 lines of code, you've got your first chart. And it looks pretty good. Plotly is a pretty sensible tool for taking that data and putting it in a nice format. And what you'll see, you've already got sort of interactive aspects. So you roll over the bars, it's telling you the date and the number of deaths here as well. And you can do things, for example, like you can zoom in on the chart. Okay. I mean, this is not that useful here, but for some charts, you might want to see a little bit closer with a certain portion of it. And you double click and you can come out of it as well. So, I mean, that's pretty neat for a little bit of code. So now, obviously, you're going to want to do something more complicated. So if you want to plot multiple series, what you effectively are doing is doubling up on what you did before. So now I'm going to plot the world and China. So here I've got my data set for the world, I've got my data set for China, and then I say on the chart for the world, I want this my X and Y values, and for China it's X1 and Y1 as well. And you just double up on the traces. So now I've got 2 traces that I want to plot. So you're basically telling it I want these 2 charts plotted on the same figure. And it's quite relatively simple. So you just add, where we had 1 trace before, you just add a list of traces. So it's important here that you remember to add it as a list. Otherwise Plotly won't recognize it. And then you can show the figure. So you can see here, you've now got China plotted on the chart as well, which is interesting. And you can see here that this little spike here was where China changed the way it started reporting deaths and cases. So there was a big spike on that day. But what's also neat about the way sort of Plotly does this automatically is, for example, I can click this and China disappears. And I can click it back on again. So I can interact with this chart to get more or less data on the chart. So yeah, now we want to tidy this up a little bit. So here's where we start adding elements to the Plotly framework. So we're keeping the same chart as before. What we've done here is we've given each trace a name, which is then going to be picked up by the legend. And what we want to do is give it some titles. So this time this is this is new. We're going to give the figure some instructions about layout. Before we were just using all of the defaults. And here we've added a title to it. So that's the title to the chart. And we can add lots and lots of other different arguments here specific to the layout. We can also add layout elements to both axes as well separately. And here I'm just adding a title. So you can see, and then we can see what's happened. So here you've now got your labels, and we've got our titles as well. So more things that we might want to do with this kind of relatively basic plot. So we want to limit the x-axis because we might not want to show all of it, and we might not want to have the chart in kind of this dimension. We might want to make it shorter and fatter, or longer and thinner. So here we're just doing exactly the same as we did before. This time we're adding parameters for the height and width into the layout. So that will just change the shape of the chart itself. We're also then going to add this parameter called range to the x-axis. You can also add a similar parameter to the y-axis as well if you wanted. But here the range is specified as a list with two arguments here. So here I've put in a date, and then I've said it like that the upper limit should be the most recent date in the data. And when we do that, you can see that the chart has actually changed shape a bit, and we've got less data. Because from January, or in January, there actually wasn't a huge amount going on, so we've got rid of some of that. Let me. So. And again, we've still got those kind of interactive elements. One other thing I just wanted to show you, hold on a second, is if you press this button, the little two arrows on top, you can also see when you roll over all of the data relating to that point, which can be quite neat when you've got multiple series on the chart. So other things you might want to do. So, I mean, we've made a bar chart here, but let's do something slightly different. So now we want to look at a stacked chart, for example, and we're gonna change it to a stacked line chart as well, just to be different. And we're going to add in an extra series as well. So here I've added another series, which is the United States. Again, defined the X and Y value for this extra series and an extra trace as well. There's then this parameter that you need to put in order to stack them. It just has to have the same name here. So it'll recognize that all of these traces should be stacked on top of each other. And then add the extra trace to the figure. All the other parameters are the same as before. And what you can see, you get a chart like this. And this is visually very interesting, because you can see how at the beginning China accounted for all of the cases basically of COVID. Then Italy took over, but the USA in recent couple of weeks has really seen a massive growth in the number of cases reported as well. So it's interesting. I mean, I think if you were to extend this, you might want to put more countries on, or you could choose, and you can see how you would, like, if there were specific countries that you're interested in, you could just change those parameters there and compare those. I did actually look at so I spent a while putting Nigeria in. At the moment, thankfully there's not much to report, so the charts don't look necessarily that impressive. So I'm kind of focusing on the countries where I know there's been a lot of cases and deaths. But when you play with it, feel free to change the countries that are being inputted there. So that's the basics plotting, and it is relatively easy, and you can see how it's sort of built up. This is a relatively simple time series chart. So let's now go and look. We're going to look at a couple of things which are slightly more involved. First, I'm actually going to skip. I'm going to come back to one. I'm going to look at the maps because I always think these are quite nice. I used to work for someone who always insisted the best way to make people think that you'd done loads of work was to make a map. And they're visually quite appealing. So to create the map, you're just importing the same packages as before, importing the same data as before. We're also importing some extra data on continents. It's actually in the repo, this data, but because I want to colour the charts by continent, I need to put some extra data into the data set to match countries to the continents. And you can see what's in the continents data set here. So you can see, luckily, in the original COVID data, there is a column, it's the one called Countries and Territories Code, which actually matches this 3-letter country code. This is the ISO3 code. So using that, we can match these two data sets in together. So again, we do the similar sort of data wrangling we did before to get the dates sorted and to get the order sorted as well. We also create a variable of the cumulative sum as well, because if you'll notice in the original data set, you've only got day-by-day cases and deaths. But actually what's kind of more interesting is to see over time what the cumulative total for each country is. So what I've done to create those is actually use the group by, because remember, we want it to sum only over one country at a time, and use the cum-sum function from pandas as well. So you end up with you can have a total cases and total deaths variable as well. We then need to add in the continents data. So this is where I'm just using pandas merge to do that, and merging on the country territory code and the 3-letter country code, which are the same. And as a result, you can just check that you've got this extra data here. So now we've got a continent name. And just to note, there's a couple. There's some places which are not classified. So, for example, the Japanese boat won't have a continent as well. So there will be a few missing in the continent classification. I've also made these are just a couple of variables which may become useful when titling the chart. So that's taking, these basically take data, or the latest data, and turn it into a string, because actually the date time format that date map in can be quite ugly, because it's got all of the minutes and seconds and everything, and when you're putting it on a title, you don't necessarily want to see all those as well. This is just formatted to show the latest date, month, and year. So, plotting the map. So this is a slightly different kind of format, but the building blocks are the same. So this is slightly more complicated. So where we had go bar before, we've now got this element called go scatter geo, and it has its own arguments. So we are creating a trace, and we're just adding it straight away to the figure rather than making a list. It's just a different way of doing things in Plotly. Lucky it has this mode, so it will recognise the 3-letter codes and plot them, so you don't have to do any extra work here. The locations, these will be, so these are the 3-letter codes in the dataset itself, and then we put in a series of parameters about the markers that we want on the map, and you can play with those, and you'll see what they do in a second. This loop here, I've actually put in because I want things coloured by continent. If you weren't bothered about things being different coloured, you wouldn't need to have this loop in here. What it does is allow each continent to have a different colour. So this is where we've created the trace. Then again, as before, we do some updates to the layout. So I've adjusted the width and the height. I've added a title, and you can use HTML tags here to kind of format the title a bit. It's a little bit ugly, but it works. And here's some other, these are layout parameters for the map itself. So you can tell it what colour the land of the map should be in the coastlines, and all sorts of things that you can play with from a stylistic sense here. Then you do figure show, and you get something like this. So here you can see the bubbles are the size of the total coronavirus deaths. So these are the cumulative deaths. And what's nice is you can see that as you scroll over, you can actually see the total number of deaths coming up as well. So yeah, it's kind of nice to sit in a map, and you can zoom in and zoom out here as well. And what's actually nice is if you've been playing about with it too much, you can just reset it and it will go back. And you can also, in the same way before, just remove Europe if it's too big and have a look at what everything else is doing as well. And it's kind of, I mean, I think the one thing this chart really brings out is just how significant the deaths have been in Europe so far, even compared to Asia, where the outbreak started as well. And you can see this kind of significantly growing bubble as well in the US. Luckily so far, not so much in Africa, but fingers crossed there. That's the map. Now I'm going to take you through another kind of slightly more sophisticated chart. So again, we're going to read in our packages, and then we're also going to read in our data. We are going to do the same transformations we've done before, so sending date to date time. We are going to sort our values by country and date, as we did before, so things are in the right order, and we're going to re-index it. Now, the chart we're going to make, are these ones, and I don't know whether you're familiar with them at all, but I've seen many different versions of the same chart. These ones appeared in the Financial Times in the UK, but just taking a few minutes to kind of understand what is going on here. So what you have is a chart which is showing, so on the x-axis you can see you've got, this is for death, the number of days since the 10th death. So every country starts at 0 once it surpasses 10 deaths. So what that means is at day 10, this may be mid-March for Korea, but this is early April for the US as well. So we're going to have to do some stuff with the data to get it in the right format here. But also note what's going on as well with the y-axis. It is not a normal axis. What has been done here is we've seen the axis logged. So it's using a logarithm. And what that enables us to do is actually look at the growth rate of the virus rather than necessarily the numbers themselves. Because if you see as the curve bends over, that means the growth rate in deaths or in cases is actually falling. And that's, I mean, you may well, if you've been following a lot of the coverage, it's something that people have talked a lot about flattening the curve. And so most countries in this, we're doing Spain still at the time of that this chart was created, it was last week, was still seeing a very similar rate of growth. So they weren't at the time seeing a slowdown in the rate of growth. It's also in most of the charts you see this line as well, which we want to put in, just showing like how fast the growth rate is increasing as well. And we've also clearly got a number of different countries on here as well, so we'll want to put those on. And you can see here is a very similar thing done for cases, but just indexed in a slightly different way as well. So this is what we're going to try and emulate, so that you can have your own version that's also interactive as well. So firstly, we need to create the variables. So as before, we're creating here the cumulative sum variables for each country. So all the cases of the UK are summed over time, all the cases of the US are summed over time, so that in the latest date it has the highest number. What I'm also going to do is create some functions. Now, when sort of coding in Python, it's always a good idea to try and, once you've written your code, try and take any repetitive tasks out into functions which you can then apply, because it makes the code generally easier to read and quicker to write as well. So I've written a couple of functions that are going to help us here. So this make chart data is going to take out, well, is going to, for each line, each trace we want to make, it's going to make chart data, so the data that we're going to use. Because we're going to want to use every single country, we can just apply this function to the whole list of countries to get a separate data set for each country. And the second function is a little bit more complicated. So here, this is where we're going to do the re-indexing of the data. Now, as I said before, if we go up, we can see that at the start, at the moment, the country reaches 10 deaths. The data set, as it stands, is arranged in date order. So if you plotted it, these lines would be at all different positions. So what we need to do is shift all of the data so that for each country, the day when it surpasses 10 deaths, or or whatever number we choose, becomes index point 0. So what I've done here is created a function which takes the data set. It takes this argument here, which is the variable. So this is the choice between, do you want total cases or do you want total deaths, so that we can use it in both cases. Then what it does is essentially it says, okay, what's the first day, and it's so it'll define for that, for each country or data, the index number, which the default here is 10, and then it'll shift the data set back by that number. And hopefully I could show you in a minute exactly what it does. Now, in some cases, there's no data at all, so this function won't work. So hence, we have a try except loop here. This is probably better for you to have a little play with what this does, rather than sort of talking through its only helpful level. Okay, so let's create the basic chart. So here we're choosing a few countries that we want to have a look at. We're going to look at total cases. We decided we're going to index to the first day that the country passes 100 cases. Then what we're going to do is going to create a series of objects for collecting the data frames, the traces that we need for plotting, and for collecting those traces at the end. So here we apply our two functions. We make the chart data first. So we get an indent for that country, we get its specific data set. Then we re-index on the total cases variable back to the point where that country passes 100. We do this, what we can see, we get a chart like this. So just to show you what is going on here. So here you've got Italy, China, and the United Kingdom. So at the moment we've just got a normal axis. And so you can see what happened with China here. So China's had the disease for far longer than any other country, hence the line extends out a lot longer. And we can see for a long time it had the most cases, but then was surpassed by Italy, which has seen cases growing more rapidly and hasn't achieved this flattening that China did. And on here I put my own country, the UK, as well, and you can see, for all intents and purposes, actually seems to be following the chart of Italy as well. And like before, you can toggle on and off different chart elements as well. So here's they're the building blocks of this chart. Now, what we want to do is not just plot those four necessarily. What we want to be able to do is choose whatever countries we want to look at. And also at the same time, I'm going to add a few axis labels as well, because it's always good to see what's been going on. So what we're going to do is, instead of before just having a list, what we've done is just taken every country from the data set by just using this unique method from the on the list of countries. And then we're just using exactly the same code as above. I then added those layout features, so put the title in, and I made it a bit more complicated because so that we can update the title every time we change the index value, or we want to change between cases and deaths. I also don't like it when in the titles there's an underscore between words. So these splits are just removing the underscore. So, and when you run that, this is what you get. So it looks very colourful, looks very nice. And so you can see here you've got a lot of countries, and if you can look at lots and lots of countries together, it's very nice. And you can deselect and reselect as before. So that's fine. I guess though, if you're looking at this and you want to just look at a few countries, it's a bit of a tedious task to go and deselect every single element of this till you end up only with a list of out of 204 that you actually want to see. So there is a solution to this. So what we're going to do is create a default list of countries to show on the chart, and then allow the user to add further ones as they like. So this is your, I've just chosen a default list of countries I know have a lot of data already. And then what I've done is extend this. Before we only had one, we didn't have an if-else statement here. But what this does, it says for all the countries in the default list, they're just traces are made just as they were before. If they're not in the default list, then I've added this argument. It's called visible legend only. And what that does, it says it should only appear on the legend and not on the chart. So I also said we were going to, at the same time, change the scale of the axis. So we're going to make it to a log axis, which is very easy to do. The only complexity comes once you change it to a log axis, is that then you have to, when you give it instructions about what the range should be, you also have to talk in log terms. So here, to set the first value of the y-axis, we actually have to do the log of the index here, and 6 is actually the log value rather than the absolute value of the upper range that you want the y-axis. So if we can then show this, and this is what you get. So you can see here that now the charts are starting to look a little bit more curved, and you've got a series of you've only got sort of what would be six or so different countries on here as well. And again, you can if you're interested in what other countries. So if we add India to it, India has now appeared, for example, on this chart. And because we have so many countries, we end up repeating countries, colours on this chart. It is a problem. I mean, you can make your palette much bigger, but you'll always end up having a couple of colours that are very similar. So it's really up to the person making the chart what they want to show in the first place, and then selecting their colour scheme carefully to make it sort of visually appealing. So that's that. The next thing we wanted to do was actually to add a rate of increase. So we just want to add a line to help people visually understand what is going on here. So what we do is a couple of things. So we basically define some new traces which will be straight lines on this chart. So just as you are creating traces, these are just you just the x value of the chart. The y values you basically have to calculate. So what I want to show is what's the line for decimal cases doubling every 3 days, every 2 days, and every 7 days. So here you just have to work out, this is just a formula to work out how it will look on a log chart. So you can play with that in your own time and see what happens when you change those numbers. There's 3 days, 2 days, and 7 days. So we just defined an extra trace, which we add into the list of traces that we're going to plot. What we also want to do is to add annotations, so people know what these lines actually mean. And so this is a function of Plotly where you can actually add onto the chart text. The thing is, you have to tell it exactly where to put that text, which can be relatively time consuming in itself. I mean, for these, I just did it visually. I looked at the chart and moved them around by changing these x and y coordinates, which basically say where on the chart you want them to be. But you can write formulas to place them in specific places as well. And then you just put whatever text you want, and you can put some more formatting parameters as well, if you like. So here I've just added those 3 annotations for the 3 lines. Then we put those all together. We've got our layouts. In the layout, to include the annotations, we have to include an extra argument here, which is telling the figure what the annotations are. And because I've called my list of annotations, it's annotations equals annotations. I think everything else is the same here. So you can see this is what you get. Let me see if I can. There we go. Here you've got these lines which show you, okay, so if your line is as steep as this one, your cases are going to be doubling every day. If it's as steep as this one, it's every 3 days. If as steep as this one is doubling every week. So you can see at the beginning, some of these countries were seeing cases double every day. Most of them have kind of flattened off, so they're not doubling every 3 days anymore. Some are still sort of between 3 days and a week as well. What I've also done, you actually see on the legend that you can click on and off these lines as well, if you like. I've also on these as well, on the lines, included the hover info equals skip. And what that does is every time I roll over the line here, I can see the information on Italy. I've actually turned it off for these lines, just because when I was looking at it all the time, it got quite annoying. So I decided not to look at them, not to have them on, but completely sort of a matter of style, a matter of choice. So that's most of the chart, really. I've done a few final bits of tidying up. So I've formatted the hover labels. I've added a subtitle and a footnotes. And as before, because I told you I don't like the underscores in country names, I've got rid of those as well. So it's basically the same plot as we had before. But here, so in this argument when you're making the trace, this hover template, what you can do is you can format what appears in these little boxes when you roll over. And here it's kind of quite ugly, I will admit. It's a mixture of HTML and Python in here, but again, it works. So this basically puts the text values that you specify here, the word cases, and also then puts whatever the Y value is as well into your label. What else did I say I was going to do? Yeah, so I had a subtitle and footnote. The way I add a footnote is just in the same way I added an annotation. So I write the annotation. I give it some instructions about approximately where I want it, which are these X and Y values here, and then I just append it to the annotations as well. Again, in the layout, you can play with all sorts of things. You can change the title font, you change the type of font. There are millions and millions of different formatting parameters that you can then play with to make to personalize your chart here, and it's well worth just having a look at the documentation to see what's going on. So then there is your complete chart, and you can see here you've got a little sort of footnote included here, and the hover labels are now kind of formatted in a slightly different way, and you can read off them as you like. And then we can just use basically the same code to plot deaths rather than cases. We just need to change the var we're using. We also need to change the scale of the axes because there's been a lot fewer deaths than cases. And we want to choose change the indexing point. So, but other than that, it's basically the same chart. So if we can run this, and what we can see is that this is the outcome. So again, and you click the button in the corner. You can then compare what's happening at each sort of day of the crisis across countries. So those are those charts. I just want to check in whether there's any questions. I realise I've been steaming ahead and I'm trying to find out if there's any questions. I will take it as a no.
Drop your questions in the question box, the chat area. If you have any question, you can drop the question in the chat area and we'll answer them.
I'll just give you a minute for a break.
Yeah.
Okay. Cool. So no questions so far. Don't know whether that's good or bad. So that's a slightly more complicated type of chart. Now we can talk a little bit about animated charts. These are fun. So the animated charts that just show basically a little video of things happening. So again, we're importing packages, we're reading the data, doing the same kind of cleaning as before. We create the same cumulative data series. And now let's just think about the kind of chart. There's lots of different charts we could plot. But what I was going to do is plot, basically animate the following chart. So this is just a chart of deaths by country. So this is a snapshot in time of the data. And what I want to do is basically show how that evolves over time in an animation. So to do that, there's actually a couple of things we're going to do. So firstly, we're going to add a slider so that the user can slide between dates to show how this data looks at a different point in time. So firstly, so we have first thing to understand, in its kind of basis, it works in a similar way to all the charts we've been seeing before. We have to define the traces that we're using, and we also have arguments for the layout as well. But what we have to include to create the slider is an extra argument layout function that tells it which steps to take as you scroll through the slider. So what we basically need to do is go through each data point and add an extra step. So this is what we are doing here. Then we add those to this term called sliders. And this slider defines what the slider looks like and then defines what all the steps are as well. And each of these steps corresponds to a trace that we've made, because we've made a trace for each of the days in the data set as well. We can then add layout terms as we would have done before. But remember, we've also added an extra term here, which is to include the slider. And it has all the information that is in this sliders object here as well. So when we do that, what we see is we end up with something like this. So what you can do, you can see that this is where we are today, but if we went back right to the 16th of February, it was only China that really had cases, and then that grew over time. So this is deaths actually, and you can see that more and more countries experience deaths, and so have appeared on the chart as well. So that's quite an interesting sort of way of viewing snaps across time. But we want to do a little bit more than that. So what I want to do is, so that's just adding a slider. I actually want to add something that we can play as a little video and watch it evolve over time. But also I want to make it visually a little bit more interesting. So I'm going to color code it by continent again, just so you can see how the pandemic really shifted from Asia to Europe. So as before, I'm going to add in all of the data on continents, match it into the original data set. I'm then going to create a number of objects, lists, strings, and dictionaries that are going to be useful when we're plotting this chart. So firstly, I'm going to make a series in the data set, which is the date as a string, because actually the animations plotly struggles a little bit to deal with date time formatted data. So I'm going to use it actually as a string. I'm then going to make a list of days. So these are all the days I want it to animate through. I'm also going to make a color dictionary so that I can map continents onto their colors. And then I'm also going to say, okay, I only want a certain number of countries on the chart, because once you've got 150 countries on the chart, it's actually really difficult to see. So I only want to see the top 20. I'm also going to put in case I want to change a threshold. So I might want to say a country should only appear once they've reached 10 deaths or something like that. But I'm going to set it for 0 for now. So this gets a little bit more involved. Again, the elements are effectively the same as before, but this time you need to create a list of frames which the animation is going to run through. But what you do is you start off with one of the snapshots, and that's
SAP, Oracle, etc.
Hello, please, I can't hear. I can't just hear anything. Hello.
Yeah, hello, Rachel.
Hiya, can you hear me? Hello?
Yes, I can hear you. Yeah, I can hear you.
Sorry. I think, yeah, the internet sometimes fails you. Sorry, I was just going through it. So this is the code to make the animation, right? And I suggest you go through it in your own time. But what we can see, so we've got the slider at the bottom as well. So if we do this, we can create a little animation over time. You can see that as time progresses, you then get more and more countries on the chart as well. And then you can go back to a different point in time, and there you can see, mid-March, China had easily the most deaths. A couple of weeks later, Italy and Spain were charging ahead as well. And this principle of animation can be quite easily applied to any charts. It just takes a little bit of thinking about how to describe all of the frames that you require. So that's the chart. And just to finish quickly, I'm just going to talk a little bit about, once you've made these charts, how you can help other people to see them. So, the same as before, you've got all your charts in this workbook. I won't go through all of these again. Safe to say, so I've got four of the charts that I produced before here. So this is the most recent one as well. So this is figure 4. And then if you want to share your charts with other people, you've got a few options. Firstly, you can use Plotly's Chart Studio. To do that, you'll need to sign up for an account, get an API key. It is free, but you have to sign up yourself. You'll then need to get a username and an API key. I've written mine in a separate file so that I don't have to, they don't appear on GitHub and someone else can use my details. You can just import those. And then it's actually, the code's quite easily. So you can then deploy it to Chart Studio. Now, if the internet's working, this might. It should then load. And this is a link I could share with then you could, and that's when it doesn't work. Hold on a second. Yeah, I have to go through that. Right, try one I did earlier. Yeah, there you can see it's deployed on the internet, and I can share that link with anyone. So that is live on the internet. Your second option is to just get the HTML. So using the simple command, you can write basically an HTML file by just, I can just do this, and you come up, it produces this HTML file, and I can just click on this. If I go trust HTML, you can see here's the chart. I can open it and actually see I open with, I can just see all the HTML code behind it. It's a little bit ugly, but if you have your own website, this basically contains all of the information you'd need to recreate that chart, including the data as well. So that's another option for you as well. And the last option is to do create a Plotly dashboard. So Dash is a package designed to help you deploy and make your dashboards. And it takes the individual Plotly charts you've made and basically formats them into an app. So that's what I showed you at the beginning. But I mean, the code is relatively simple. This is kind of your basic Dash app. Let me see if I might have to rerun the workbook. So this is now running locally. I just put that there.
Yeah, hello, Rachel. Sorry, I can't see your screen. I don't know if it's only me, but I'm just seeing the.
Oh, sorry. Hold on a second. It says I'm sharing. I'll stop sharing and reshare.
Oh, you're not sharing your screen. Okay.
Is that correct?
Yes. Okay, I can see the screen now.
Can you see it now? No, let me just get on. Can you see the chart? Are you seeing a chart now?
Yes.
So sorry, let me just right, you can see now your chart is running locally. And you can add multiple charts together, and again you can style the Dash app as well. So I've just done something very, very simple here. So I've just added all of my 4 charts into a little app. And there you go. That's what it looks like. And you can make your charts. Then, if you have your own deployment platforms, use those. You can use something like Amazon's Elastic Beanstalk, which has a special kind of wrapper to help you deploy these sorts of dashboards. But there you go. It's only, that was one workbook of code, and you've got your own dashboard, which you can rearrange and format to your heart's content. So that's it from me, really. I mean, I realised that was a bit of a canter through quite a lot of code, and I'm not sure how much you all heard, but thank you very much for listening. And if there are any questions about the code or whatever, then please do feel free to get in touch.
Yes.
Thank you.
Yeah, thank you so much for this. We've had a very nice session today, and I really appreciate this. And so okay, someone. Okay, yeah, back now. Someone chipped in. There's a question as regards the modeling.
Yep.
The particular code to a model. How do you
I can't hear
this into a model?
But could you repeat that? You were cutting out.
Okay. Okay, yeah. Sorry about that. I think it's a network issue. So now there's a question. The question is, how do we convert this to a model? Say, for example, you're working on a project and you need to implement this particular Plotly code in a model or something like that. How do one convert it into a model?
I think you would be using the same principles. I mean, I'm trying to think of a good example. So let's say you wanted to show, I don't know, the coefficients from a regression, for example. You would need to take those and format them either as a NumPy array or like a pandas data frame, and then you could plot them, as a bar chart or something like that. Or if you wanted to show, for example, you were running a neural network, and you wanted to show the trading loss and the validation loss over time, sort of with the number of iterations or epochs, what you could do is output from your, as part of your network training, a NumPy array of values for your loss, and then feed them in to a Plotly chart in the format, in the same way, in a similar way that I've been showing you there. So you might want to choose a Go scatter. You have your X value as your number of epochs, your Y value as your loss, and then you could show that as a static Plotly chart, or show that as an animation over time. I hope that answers your question.
Yes, answer the question. Okay, yeah. Then someone else posted a question as regards where can he get the link, the Git link. Okay, I think we'll okay, for those joining, we're going to post the link via the emails of everyone registered. We'll post the Git link there. Although we sent it already, but if you don't have it, we're still going to send it via email.
Okay.
Any other question again? Eniola, Olawale, okay, Emmanuel. Are there any questions? All right then. So in the absence of no further questions, okay, I guess we've come to a wrap. We are wrapping up the session already. I really want to appreciate Rachel for taking out our time to take this webinar with us, and it's been a very interesting one. Been a very interesting one, taking us how to go around Plotly. I know recently back there when the team was working around an hackathon project, and they were required to use Plotly. I think Plotly was a challenge for them, and I think this particular webinar will kind of expose this, kind of shows, it's very expository, it shows everyone how to go around Plotly with Python and for data science. If I may ask, is there a way you can combine Plotly with Microsoft Power BI?
I'm going to have to pass on that one. I don't know. I mean, my sense is, having used Power BI, that Plotly is a little bit more flexible. I mean, so in terms of if I was choosing, but you can embed Python objects in Power BI, but whether you can get the interactivity, I don't know.
Oh. Okay. All right. All right. All right then. All right then. Okay, thank you everyone again for coming. Thank you for your time, for attending our second edition of our webinar, from machine learning to this. We appreciate your time. For everyone that joined us, we had people joining us from India. We had someone from Bauchi, not Nigeria. We had from Abuja and Lagos, Ibadan, and Ogun State. We really appreciate your time. We appreciate your time for coming. Thank you again. Let's see. I think. Okay, yeah, we have Emmanuel Joga from Lagos. Emmanuel, if you have a question, you can post your question as well, and let us know if you have any question. And okay, Suleiman was asking if okay, the session video will be made available for everyone via the link, via the email rather. So we get to have the video session for the webinar. Okay. Any other feedback again in that question? All right then. Without wasting further time, yeah, thank you everyone. So we've come to an end of today's webinar. Yeah, see you some other time.
Thank you.
Yeah, thank you, Rachel.